This week, we're going to be talking about relations and functions. So these are kind of really fundamental ideas, especially the idea of a function is something we're going to look at all semester long. So we want to make sure we have a good grasp on what's going on here. Now, a relation is just a very general term for grouping things together. So this can be all kinds of things that we already know about. It can be the way that you use the word relation in reference to like relationships. So, for example, I could have myself and the people in my family, right? So maybe my immediate, like biological family, right? Mom and dad. And then I've also got one brother. There are all these relationships. We are related to each other if we include things like, the legal like relationship part of it, then they're related. If I start adding in my now family, right, I could add in my wife, could add our kids, kid one and kid two. People thought those were weird names for them, but I think it's fine. And all of these people are related. They're related to each other. So again, just a like very general way of grouping things together. So I'll just say general way of pairing two things together, no extra conditions on it or anything like that. Um, in the sort of math context, a lot of times we will write these as ordered pairs. So I could represent, say, one of these relationships, maybe this one, as an ordered pair by saying me and dad are related to each other. There's not really any particular reason I chose this order rather than that one. I could have done it the other way around too. If I did that for all of these, I'm not going to write them out, but you know, just imagine I could then group those together as a set. Curly braces like that means just all of those things go together, and then there you go. There's me and all of my sort of family relationships as a relation. Now, a function takes this idea and sort of cuts it down a little bit to be a little more specific. So for a function, we want to basically take this same idea and look at how things are paired together, but in a way so that I can almost think of it like a question. Um, so, for example, I could say something like, who is your mother? I mean, biologically here, right? So there's kind of two parts to think of that as the input, right? Or the, oh, I'm forgetting my English. I'm not sure if that's the subject of the sentence. That was a long time ago. Doesn't matter. Not English class. The person that the question is being directed toward, right? And then what are we asking about? Think of as the output. So to again kind of write this as an ordered pair, might look something like that. Okay, and this doesn't seem right now like it's all that different than what we were talking about here. The difference is that here, because I haven't put this extra, like more specific condition or question on it, I get paired up with a whole bunch of different people, right? Every one of these little lines that's sort of connecting to the me bubble, excuse me, right? Every single one of those represents a different ordered pair. So this is like saying, hey, who are you related to? Well, I'm related to a bunch of people. There are a bunch of answers to that question. Who is your mother, though? And again, like biologically, right? So there's only one of those. There's only one possible answer to that. So the thing that makes a function is that it works like that. Whatever is here, whatever the input or the sort of question part of it is, there's only one possible answer in a function. So a function always pairs an input, right, which is this, to one. When I say one, I mean only one output, which is like the answer part. Okay, so we'll talk about some more examples in class. We'll get some other kind of perspectives on what this means, but a little bit of terminology stuff. Domain, range. Domain is the set of all input values for a function. Range is the set of all output values. So if I'm asking about, something like this scenario, and who am I related to, the only thing in the domain might be me, right? This sort of central thing that this kind of web is all built around. The range, the output values might be all these people that I'm related to. Again, we'll look at some more examples. The purpose of this is really just to introduce kind of the terminology and get you thinking about what's going on, so that when we talk about things in class, it's not like you're hearing the words for the very first time. So let's look at a quick example. I'm going to take something that is going to look a little more like the kinds of things that we'll be doing in class and using. So I'm going to call a function f of x. This function notation just means that I'm naming the thing f, and what I'm going to use to write it down, the symbol I'm going to use is an x. So f of x equals x plus 2. This is sometimes called the symbolic form or the symbolic representation of a function. It's the one that looks like a formula. This will usually be kind of our go-to thing. Most of the time, it's nice and compact. I can talk about the function called f, and then this gives me kind of instructions for how to deal with it. Another way we can represent a function is with a table. So I could say x and f of x, and what I'm going to do is line by line just pair up the x value with the function value it goes with. And generally when I do this, I'm just trying to get an idea for what the thing does. So I'm just going to pick a few x values that are sort of nice or convenient. So I might go like -1, 0, 1, 2, and 3. Again, just a few points so I can get a feel for what's going on. Here, I'm going to evaluate this function or plug this x value in. So anywhere x shows up, I'm going to replace it with -1. And then I'm going to simplify that. So 1. 0 plus 2 is 2. 1 plus 2 is 3. And so on. This part is kind of my scratch work. These are the actual function values that I'm interested in. So what this tells me, for example, this first line is that the x value 1 pairs with the y value, oh sorry, -1, pairs with the y value 1. Similarly, 0, 2, 1, 3, and so on. Now, if you think about what's going on, there's not really any particular reason for me to choose these, except that, again, they're kind of nice and convenient and you know, going to be easy to work with. I could just as easily have said, hey, I wonder what happens when x is 1.239. But if somebody said, hey, pick a couple of x values and make a little table with some points here, like that's kind of a weird choice for the value to go with, right? It doesn't mean it's not there. It doesn't mean it doesn't exist. It's just not the one I'm going to pick if I'm just going to, you know, sort of choose a few points to look at. Okay, so that's a table representation of a function. Again, just kind of keeping up with our, you know, central idea of a function, this pairing one input to one output thing. Notice that each of these, like when I plug -1 in, I get 1 back. I don't get 1 sometimes and 5 other times. I just get this 1 value that it goes with. If I'm listing these points out, each of these x values shows up 1 time. Another common representation is to use a graph. Graph, we take 2 number lines, call one of them x, we call the other one y. Imagine that they're sort of spaced out and have little, you know, hash mark things if you want to kind of keep track of where you are. I'm not going to try to be real precise in drawing this because I'm just sketching it. But I would just take these points that I found and plot them. So -1, 1, 0, 2, 1, 3, 2, 4, 3, 5. And then again, because those are just some representative points, what this really means, if you recall from, you know, earlier classes, this is a linear function. So if I connect those, I get a straight line. That line represents the function graphically. We'll spend a lot of time talking about interpretations and that kind of thing. Some properties of functions that we can see from a graph. This is continuous, which just means you can draw it all in one piece. It's increasing, which means as I look from left to right, this is moving upward. And what that lets me do is, you know, kind of see, I don't remember what the number I wrote before was in between these, but, you know, some weird messy decimal thing, right? Well, now I can see that's going to be somewhere in here. So that y value that it goes with falls somewhere in between, right? So we get kind of a visual estimate of what's going on without having to actually find every single little value. Okay, so that's, again, an example of a function in kind of a few different representations. We'll talk more in class about, you know, how we deal with questions of finding domain and finding range and that kind of thing, but that should get us started.